Thank you, Colin. Thank you, everyone, for coming. My name is Lingteng, and I'm doing research about nuclear physics. Today, I'm going to talk about how nuclear power can contribute to solving the climate crisis, and about my project, how my project can contribute to the nuclear safety. So we all know about greenhouse effect. Right? The carbon dioxide accumulates in air, prevent heat from escaping. We can all feel the heat wave in Bristol, right? And summer is getting hotter and hotter every year. And also the sea level is increasing, all related to the greenhouse effect. So the question is, what caused the greenhouse effect? Let me ask you a question. What percentage of carbon emission come from fossil fuel? Think about number. Okay, the answer is almost 90% of carbon in air comes from fossil fuel. So if we want to solve the climate change, we must transfer to new energy sources. Okay. So here comes nuclear. Nuclear has the advantage of zero carbon emission, and it is safe. So you may heard of Chernobyl, but actually this is a totally man-made disaster, and also Fukushima. However, this is because of extreme natural disaster. So, and compared with other clean energies like solar and wind, nuclear has one advantage of high energy density. It do not require large land areas, okay? And it has a very stable output, not affected by the weather. However, there are also problems like nuclear waste and also concerns about nuclear safety. Those are what we really need to care about. So, move to my project. Almost all the nuclear material and nuclear pollutions are heavy nuclide, like uranium, and they are mainly alpha emitters. Alpha particles are two protons and two neutrons combined together. Okay, and alpha emitters is very harmful to human. If you breathe alpha emitters, it will cause lung cancer. Okay, actually, the exposure to radon gas, which is a kind of alpha emitter, is the second leading cause of lung cancer, okay, just after the smoking. And if you are very unlucky and ingest alpha emitters, it will travel around your body and remain radioactive for hundreds of years. Okay, and if you heard the story about Alexander, who is a Russian defector killed by a tiny amount of alpha emitters, you know how dangerous they are. And unfortunately, alpha particles can only travel several centimeters through air and can easily be blocked by some materials, so they are extremely hard to detect. So traditional detector need to be put close to the contaminated surface. This process is very time consuming and has a possibility of pollution. So how can we detect alpha emitters at a long distance? This problem has troubled the nuclear industry for decades. Okay, so the solution is when alpha particles travel through air, it will excite surrounding molecules and emit photons. Those photons can travel kilometers, very long distance. Okay, and this phenomenon is called alpha-induced fluorescence. My experiment is to use this phenomenon to detect the alpha emitters at a long distance. This process is very similar to take a picture with your own camera. However, we are looking at UV light, which we cannot see by our eyes, and we are using ultra-sensitive cameras. And the red picture is one of our experiment results, and we are now able to detect alpha emitters at meters distance, which is tens of times longer than the traditional methods. And our project can be widely used in the nuclear industries and contribute to the nuclear safety. So when we talk about nuclear future, what nuclear power would be? It would be safer and cleaner to use in the future. So with more energies, with more clean energies like nuclear, so the carbon in air would be greatly reduced, and we should believe that we can solve the climate change in the future. Thanks for listening, and over to you, Lingteng.